Probability of union intersection of events based on relative frequency. So we are to use the experimental probability. First, what is probability? So as we recall, probability is the branch of mathematics concerning numerical descriptions of how likely an event is to occur or how likely it is that a proposition is true. The probability of an event is a number between 0 and 1, where roughly speaking 0 indicates impossibility of the event and 1 indicates certainty. For us to determine the probability of an event, we may use probability of an event is equal to the number of ways the event may occur over the number of possible outcomes. So this is the usual way of writing probability. But this one is under in theoretical probability. But because we will be talking about experimental probability, we are to use this notation. So the probability of an event is equal to the number of outcomes in the event divided by the number of outcomes in the sample space. So this is the formula that we will be using. So this is the notation that we will be using for the examples that we will have. So experimental probability is usually being used in terms of sports. In statisticals, this is the kind of probability that they are using. The difference is that they are not writing it in fraction form, instead they are writing it in percentage or in decimal. So let us start with a couple of examples. First, let us deal with the probability to wherein the data are represented through Venn diagram. So the data below shows the number of students of Great and Diamond who participated on the following sports. So for the basketball, volleyball, and softball. Whenever that we are dealing with probability, we must be aware of the universal set or the total number of sample space that are present. So in this case, we do have 13, 2, 1, 3, 2, 11, 6, and 2. So we are to sum up all of this. So this gives us 30. So 13 plus 2, so 15, 16, 19. So we have 30, 32, 38 plus 2. Okay, so we do have 40. Correction. So we do have 40 as our universal set or the total sample space that we do have. So keep in mind that our universal set has a frequency of 40. So this 40 will always serve as our denominator for our probability. So let us now start. Number 1, so the probability of B or for the basketball. So on our basketball, so we do have the numbers 3, 13, 2, 1, 3. So we're just simply sum up all of this. So 13 plus 3 plus 2 plus 1. So this gives us 19. 19 over 40 will be the probability. So again, that over 40 came from the sample space, the total sample space that we do have, which is 40. 19 came from the total of the frequencies inside the basketball, which are the numbers 13, 2, 3, and 1. Number 2, probability of V or probability of volleyball. So for the volleyball, so we just simply count all of those frequencies inside the volleyball. So we have 11 plus 2 plus 2, so that gives us 15 plus 1. The answer is 16. So 16 over 40 based on the total sample space. So since we have 16 over 40, so this term can be further simplified. So we must be able to write the simplest form of our answer in probability. So 16 over 40 or 2 over 5. Number 3, probability of softball. So for the softball, the frequencies that we do have are the number 6, 2, so that gives us 8, plus 1, 9, plus 3, so we do have 12. So it is 12 over 40, or we may simplify this as 3 over 10. Next one, number 4, probability of S complement. So notice that letter C. So that C means complement. Sometimes this is being replaced by the comma symbol, so read as prime. But both of these notations works in the same way. So probability of S complement. So whenever that we are dealing with complement, so it is just only a matter of being aware to what is not part of S. So here we do have S. The coverage of S are these frequencies. So 3, 1, 2, 6. If we're dealing with plainly S. But since we have the notation complement, so we are going to use the numbers that are outside of S, which are not S. And they are the numbers 13, 2, 11, 2. So these are the numbers that we will use since we're talking about the complement of S, meaning not part of S or not part of softball. So upon adding all of these numbers, so 13 plus 2, that gives us 15, plus 11, 26 plus 2, so that gives us 28. So the answer is 28 over 40. Or, in simplest form, we have 7 over 10. So this is the basic way of dealing with notations using complement. Or, we may also use a different approach in looking for the complement of S. So we may have this approach. So we may just simply add the numbers that are within the softballs region. So we do have 3 plus 1 plus 2, that gives us 6, plus 6, that gives us 12. And we subtract that 12 as the result to our universal set. So 40 minus 12, the answer is 28. So it is true that the answer is 28. So 28 over 40, or 7 over 10. So that is one way of dealing with complement. So let us apply that one in number 5. Number 5, we do have the probability of B complement. So our B are this one. So we do have 13, 2, 1, 3. So adding all of this gives us 19. So the result for the basketball is 19. But since we are asked to have the complement of this, so we subtract this 19 to 40. So 40 minus 19, so that gives us 21. So therefore, for number 5, the answer is 21 over 40. Or, so this doesn't have a simplified form. Okay, so hope it is now clear how to deal with notations using complement. For number 6, probability of V union B. So probability of V union B. So first, we simply look at the union of the volleyball and the baseball. Okay? So that includes all of this area or all of this region. So adding all of the elements here, so we're going to use all of the frequencies present in this region because we are using union. So 13 plus 3 is 16, plus 1 is we do have 17, plus 2, 19, plus 2, 21, plus 11, we do have 32. So the answer is 32 over 40. How about for the number 7? Number 7, let us now deal with intersection. So for intersection, remember that we are just simply going to look for the common area or common region or common element. So for S intersection V, so S, so here is our S, and here's our B. So the common region shared by these two area is this frequencies. So 1 and 2. So 1 plus 2, the answer is 3. So 3 over, by the way, the number 6 with the simplified form 4 over 5. So number 7, going back to number 7. So the answer is 3 over 40. Okay? So again, over 40 is based from the universal set or the total sample space that we do have. Last one, number 8. In number 8, what we do have is probability of V union B complement. Okay? So first, let us look for the union of B and B. So the union of V and B are this area. So is this area. So we do have 13, 3, 2, 1, 11, and 2. But since we are going to look for the complement, so we are to use the numbers that are outside because it is complement. So we do have 6 plus 2, so the answer is 8, 8 over 40. So that is one of the approach in dealing for the complement. Or we may use the one that I said earlier, so we just simply add up the numbers inside. So this gives us 32 upon adding, then subtracting that 32 to 40. So we need to subtract the 32 to 40 because we are having the complement symbol on our notation. So 40 minus 32, the answer is 8. So it is the same as what we had upon using the numbers outside the region of the union of volleyball and basketball. Okay, so we may further simplify this as 1 over 5. Okay, so that is how easy in dealing probabilities of union and intersection. Let's have a different set. So this time, let's have the data presented in tabular form. So the data below shows the number of students who registered for the modality of the class they want to attend. Okay? So let us have the following probability of each. So for number 1, probability of boys. So, but before looking for the probability, again, we must be aware for the total sample space that will serve as our universal set for this one. So here, so we just simply add all of the numbers. So we do have 16 plus 45. So this gives us 61 plus 15. This gives us 76 plus 40 gives us 116 plus 14, 130 plus 20. So our total sample space is 150. Okay? So let us now start. Number 1, probability of boys. So for the boys, so we do have this region or this area. For the boys, so we do have 16 plus 45 plus 15, and this gives us 76. So 76 over 150 as our total sample space. Or we may further simplify this into 38 over 75. Number 2, probability of face-to-face. Okay, so for the face-to-face, we are to use these frequencies. So we do have 15 and 20. So adding these two, 15 plus 20, so we do have 35 over 150 or 7 over 30. Number 3, probability of G. G representing for the girls, but we do have that symbol again, complement. So G complement. So here is our G. Okay. So when we say complement, it is not part of G. So what are the frequencies that are not parts of G? So we may use this. Okay, so we are to use this. So 16 plus 45 plus 15. And that gives us 76 over 150. Okay. So that is the reason why we have. So that is how we deal with notations using complement. Or, again, if we can't understand that idea, we may just simply add up all of these frequencies that are within the girls frequencies po. So 40 plus 14 plus 20, this gives us 74. Subtracting that 74 to the total sample space, which is 150, still, it will give us also 76. Next one, number 4. Probability of M complement. So modular complement. So here is our modular. Since we are dealing with the complement, which means not, so not part of the modular, so we use all of these frequencies outside the modular, or not part of the modular. So we do have 16 plus 40, so we do have 56, plus 20, we do have 76, plus 15, we do have 81. So the answer is 91, correction, 91 over 150. Okay. So we cannot further simplify this one. For number 5, so let us now have the union. So for the union, so we do have O union G, or online union. So we are to unite this to G for the girls. So we just simply add up all of these elements. So 16 plus 40, that is 56, plus 14, that is 70, plus 20, that is 90. So we do have 90 over 150. We can still further simplify this, or we may have 3 over 5. Number 6, union again. So we do have probability of M union F. So we do have here M, and we are to union this or to unite this to F. Again, union, we are to use all of the elements in frequency. So we do have 45 plus 15, that gives us 60, plus 20, 80, plus 14, 94. So we do have 94 over 150, or further simplified as 47 over 75. Next one. For number 7, so we do have probability of B union F complement. So first, let us get the union of B and F. So we do have B union F. So since we are dealing with union, these are the elements that are involved. Okay? So we do have 16, 45, 15, and 20. But since there is the notation complement, we are going to use what is outside, or what is not involved in the union of boys and face-to-face. And those are the numbers 40 and 14. So 40 plus 14, the answer is 54. Okay, so we do have 54 or 150. it will also have the same result if we will be adding all of these numbers, 16 plus 45 plus 15 plus 20. So that will give us approximately 96. If we subtract that 96 as the result to 150, it will also give us 54. Okay, so the same thing pa rin. So we can further simplify this as 9 over 25. Number 8. Let us now have the intersection. For the intersection, so we are asked to find the intersection between G, which means girls, and modular. So for the girls, here are the girls. And for the modular, here are the modular. But since we are plainly dealing with intersection, under intersection, we are going to only use the common region or common element or shared area. So here, the shared area between modular and girls is the number 14, a frequency of 14. So therefore, the answer is 14 over 150, or further simplified as 7 over 75. Next one, number 9. Probability of F intersection G, complement. Okay, so for F and G first, so the intersection of F and G, so for the F and G, their intersection is here, 20. But since we are dealing with the complement, we will be using what is outside of 20. Or, to make it a bit faster, we just simply subtract this 20 to 150. Therefore, that gives us 130 over 150. Or further simplified as 13 over 15. Okay? So, hope you are following the concept and the process in dealing with the probability of union intersection of events. Let's have a different set now. The last set. So this time, let us have the elements written or listed. So we do have set E. We do have A, B, C, D, E, F, G, H, I, J, K, L. For B, we do have the vowels. By the way, keep in mind that the first set is the one that usually holds the most number of frequencies. They are called the universal set. So meaning, all of the elements present on the following sets or the subsets for set V, C, and X should be visible on our universal set, which is our set E. So in letter V, we do have the set builder form written as the vowels. So even if we are aware that the vowels are the A, E, I, O, U, but since O and U is not visible on our universal set here in set E, so we cannot include O and U. Instead, what we can only have are the letters A, E, and I, because these are the only letters that are present on our universal set. These are the only vowels, rather, that are present on our universal set. For set C, we do have the consonants. Again, we are just only going to write down all of the consonants that are present on our universal set, or which is in set E. And these are the letters B, C, D, F, G, H, J, K, L. And for our set X, we do have A, B, F, G, H, I, L. So let us now start dealing with the probabilities. So for number 1, probability of E, so we need to do counting because our elements are listed. So we do have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our universal set or our total sample space is 12. So this will serve as our basic denominator. So going back to number 1, probability of E. So we do have 12. So therefore, our answer is 12 over 12 because our universal set is 12. Or, we may simplify this as 1. For number 2, probability of V. So for set V, we do have 3 elements only, A, E, and I. So we do have 3 over 12. Okay? So we do have 3 over 12. And we may simplify this as 1 over 4. For number 3, probability of C. For our set C, we do have how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, our answer is 9 over 12. Or simplified as 3/4. For number 4, probability of X. Count of 1, 2, 3, 4, 5, 6, 7. So the answer is 7. Should be 7 over 12. So this corrected. 7 over 12 should be the correct answer. Okay? So, these have no simplest form. For number 5, probability of V complement. So, for V complement, so first things first, let us determine the probability for V. So, for the probability of V, we do have 3 elements. So, as what I said, there is one way of dealing with the complement is by simply subtracting the present element to the universal set. So, for our V, so we do have 3. Okay? So, we just need to subtract this 3 to our universal set or our total sample space. So, 12 minus 3, the answer is 9. So, therefore, our answer is 9 over 12. Or simplified as 3 over 4. Next one. Number 6, we do have the complement notation again. So, we do have probability of x. So, for our x, we do have a total number of 2, 4, 6, 7. But since we are not dealing with x, instead we are dealing with the complement of x. So, we subtract this to our universal set. 12 minus 7, the answer is 5. So, therefore, we have 5 over 12. So, we can further simplify this one. For number 7, we do have the union. So, the union of V and C. So, V and C. So, counting the elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, the answer is 12 over 12. Or 1. For number 8, probability of X union B. So, X union B. So, these are the elements that we will be dealing. X and V. Okay, so we count off 1, 2, 3, 4, 5, 6, 7. Then, we are not going to count A anymore because we already counted A. So, 7, 8. Okay. I won't be counted anymore as well because we already counted I on set X. So, the answer is 8. So, 8 over 12. Or simplified as 2 over 3. Number 9, V union X complement. Again, to deal with complement, one way is by simply subtracting the result of the initial notation to the universal set. So, we do have V union X, V union X. So, we do have 1, 2, 3. So, won't be counted anymore. 4, 5, 6, 7. Not this one. So, we do have 8. So, we're going to subtract this 8 to our universal set because we are dealing with the complement. So, 12 minus 8, the answer is 4. So, we do have 4 over 12 or 1/3. Number 10. Probability of C union E. Complement again. So, again, to deal with the complement, we first deal with the initial notation. So, C union E. So, C union E. So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 10. Not this one anymore. 10. 11. Not this one. We already counted these letters. 12. Okay. No, not anymore. Not anymore. So, the answer is 12. So, subtracting that 12 as our result to the universal set. So, 12 minus 12, the answer is 0. Therefore, we do have 0 only. So, not 0 over 12 anymore. So, once the answer is 0, plainly 0. Next, number 11. Probability of X intersection V. X intersection B. So, where is our X? So, there it is. So, our X and B is the one that we are going to deal with now. So, X and V. So, we are intersection. Intersection, we are going to count off the common elements, or it is only the common elements between set X and set V. So, on our X and B, the common elements are only A and I. So, no more, no less. So, there are 2. So, the answer is 2 over 12. Or in simplest form, as 1 over 6. Number 12. Probability of E intersection V. Okay, so let us now deal with the different sets. E intersection V. So here is our E and here is our V. The intersection using the common element only, so we'd have A on both these elements. 1. Both do have E, 2. Both do have I, 3. So the answer here is 3 over 12. Or in simplest form, 1 over 4 or 1/4. Number 13. C intersection X complement. Again, so let us first deal with the intersection of C and X. So C and X, let us look for the intersections. Let us look for the common elements between C and X. So for C and X, both of them do have B. Both of them do have F. Both have G. Both have H. Both have L. So the answer is 5. So the common elements between C and X, because we are talking about intersection, the answer is 5. But since there is a complement notation outside, so we subtract this value to the total number of sample space. So 12 minus 5, the answer is 7. So the answer is 7 over 12. Last one, number 14. So probability of E intersection C. Probability of E intersection C. So look at the common elements between C and E. So C and E. So what are the common elements? Both do have B. Both do have C. Have D. Have F. Have G. Have H. Have J. Have K. And have L. So upon counting, we have 2, 4, 6, 8, 9. They do have 9 total number of elements. But since again, our notation to have a complement outside, so we subtract this to the universal set, which is 12. So 12 minus 9, the answer is 3. So we have 3 over 12. Or in simplest form, we do have 1/4. Okay? So hope with those examples, you managed to understand how to deal with the probabilities of union and intersection of events in a relative frequency approach through experimental probability. Okay? So, thank you for watching. See you next time.